The digital biology paradigm means that we are empowered to be engineers of living things and to find ways to harness nature's solutions to our benefits. And like I mentioned, the paradigm says that anything that we can do with computer code, we can also do with DNA code. So for example, if we want to write DNA code from scratch, that's called synthetic biology. That is also an exponential technology. It needs to get cheaper, but people are working on it, so that's good news. We can move big blocks of code around, just like coders do in a computer. If we do that, we can do that within an organism, or we can move those blocks outside of an organism to another species. That's called genetic engineering. We've known how to do that since the 1970s. But there's a new set of technologies, new like last 8-10 years, that are really getting a lot of spotlight. And these are called gene editing technologies. The most famous one you've probably heard of, it's called CRISPR, but there's a whole bunch of these gene editing and base editing technologies that empower people to debug the source code of life one letter at a time, and to do it precisely and permanently. It's a game changer. And again, expect to see more of this in the coming years. I'm really pleased to say that India is taking a leadership role in supporting its bioeconomy through agriculture by setting guidelines that clearly reflect this new era of gene editing. This is not GMOs. This is something fundamentally different, and I'm really pleased to report that India is looking at it that way. So well done, because what that means is that the innovation can come to a favorable regulatory environment, because we want our products to be efficient, we want them to be safe, and we want them to be trusted.